begin with the lecture 4 on unit 3, that will be curve fitting. Okay, now what is this curve fitting? It is actually similar to what we learned yesterday, that is regression regression lines. What happened? We are having a tabular values of x and y, and there are different types of curve passing through these points x and y. It may be a line, it may be parabola, it may be some other curve. Then how to find that equation of curve? What is the best possible equation of curve we can get which passes through these maximum points? And that we can get by using curve fitting. So this is one more way to find the equation of curve which passes through maximum number of points. One of the ways by using regression lines, and this is one more way, that is another way to find the equation of curve passing through maximum number of points. Okay, now there are different types of curve we can find which pass through the points, and that standard curves we are going to see are the first one, that is a line y is equal to a naught plus a1x, that is a straight line. Okay, by regression we get two type of straight lines, that is regression line of y on x and x on y. Like that we use one more method to get the equation of straight line y equal to a naught plus a1x. The another type of curve which we get by using this method is y equal to a naught plus a1x plus a2x square. This is the parabola or quadratic curve. Okay, this is the equation of general equation of parabola. Okay, y is equal to a naught plus a1x plus a2x square. If a naught and a1 are 0, then we get y equal to a2x square. That will be the parabola which passes through origin. Okay, that is some standard equation. This is the general equation of parabola. Okay, so we can also get the equation of parabola which passes through the tabular values of x and y, maximum number of points from that tabular values. Then this is nth order polynomial, nth degree polynomial curve. Okay, any, it may be degree 3, degree 4, any higher order polynomial if you want, that also we can get by using this curve fitting. The next is y is equal to a b raised to x. Okay, we are having some some constant terms. A and b can be any numbers, not necessarily integer, it can be any number. So if we have if you want the equation like this, y equal to constant into constant raised to x, this equation we call as a such type of curve which satisfy this equation is called as a exponential curve. So how to get the exponential curve, that also we are going to see. And one more last type, that is y equal to constant into x raised to constant term. A and b can be any numbers, it is not necessarily integer. Okay, this we call as a geometric curve. Okay, a and b are any numbers, not necessarily integers, it can be any, it can take any values. Okay, so how to get all such type of curves? Okay, by using the tabular values. This is a very easy method. Again, we have to remember some basic formulas and the format of the table. If we remember that, we can easily get the curve which passes through the values of which passes through the points which we get from the table. So we'll one by one we'll see what are the methods. So firstly, we consider about the straight line. So if you want to find a straight line which passes through that points x and y, in that method we call as a least square method. And what we have to do, suppose we are given n tabular values, n points, and we want this straight line y is equal to a naught plus a1x. Then firstly, take summation of this equation on both sides. So if we take the summation, then summation y, we can write it as summation y or summation yi, any notation you can use. A naught is a constant, and if you take the summation of a naught or n number of times, then it becomes n a naught plus a1 into summation x, because a1 is a constant, a1 will come outside, and this will become summation xi. Okay. Same way, now we got one equation. These values of summation x, summation y, we can get it from the table. N means number of observations. Okay, that we can get. So we got one equation in terms of a0 and a1, and we want to find the equation of this line. That is, we want to find what are a0 and a1. So for getting a0 and a1, to find two unknown terms, we must have two equations. So how to get the second equation? So for getting the second equation, the method is multiply this first equation by x and again take the summation. So multiply first equation by x, it becomes xy equal to a0 x plus a1 x square. And by taking summation, it becomes summation xi yi equal to a0 is a constant, take it outside, into summation xi plus a1 into this become x square, so it is summation of x square. So how to get the next equation? Multiply the given equation by x and take summation. So now we got the two equations, equation number 2 and 3 in terms of unknowns a0 and a1. All these summations which we can find out by using the tabular values. Okay, and then solving these two equations simultaneously, we get the values of a0, a1, and put these values into the first equation. That gives us the equation of straight line. Okay, and these equations, equation 2 and 3, these are called as a normal equations of 1. Okay, so very easy, just we have to take the basic equation first, equation of straight line. First take the summation of that equation on both sides, then multiply the given equation by x and take summation. Okay, we get two equations. Now put the values of these summations from the table, and then we get the two equations in two unknowns. Solve that two equations simultaneously, we get a0 and a1. And putting that a0 and a1 into first equation, we can get the solution. Okay, no separate formulas to remember. Just whatever equation of line we want, take that equation, take summation, multiply by x, and then take summation. If you are given the equation of line as x is equal to some constant plus constant into y, then in that case, again, we take the summation first. And if we have x here, then in that case, we multiply by y and we take the summation. Okay, so if you are having equation as y in terms of x, multiply by x, take summation. If we are having x in terms of y, then multiply both the side by y and then take summation. Get two equations and solve simultaneously. Okay, and the method by which we get these unknown terms, this method is called as a least square method. Okay, by using the conditions of maximality and minimality and doing the simplification of this given equation, we get these equations. Okay, now we'll take the problem and we'll see how to make use of this technique to get the equation of straight line. So consider the first problem. Find the least square straight lines for the following data. Values of x are 1, 2, 3, 4, 5, 6, and values of y are 6, 4, 3, 5, 4, 2. And estimate y at x equal to 4 and x at y equal to 4. Okay, now here we want both the straight line. The first straight line will be y is equal to a0 plus a1x, and other straight line will be x in terms of y, that is x equal to some constant plus constant into y. Okay, now for that we require a table, and in table we want x square, y square, x into y. So first make a table, x square, y square, x into y. Okay, n will be total number of terms. Now there are total 6 terms, so n is 6. Okay, now take the sum of these columns. Summation x square, it is 1 square, 2 square, 3 square, 4 square, like that. Take the square of each x. Take the square of each y and take the product of corresponding x and y. 1 into 6, 2 into 4, 3 into 3, like that. Take each product. Okay. So like that, complete this table. Okay, 6 square 36, 1 into 6 is 6, like that. 4 square 16, 5 square 24, 4 into 5 20, like that, completing this table. And now take the summation of each column. Okay, taking the summation of each column. Summation x is 21, summation y is 24, summation x square is 91, summation y square 106, and summation xy is 75. Now, take the basic equation of line, take the summation of that equation, then multiply by x, take summation, and then put these values from the table in that equations. Get two equations in two unknowns. And solving that two equations simultaneously, we can get the values of unknown terms a0 and a1. So to begin with, we take the terms equation of straight line y is equal to a0 plus a1x. Then normal equations are nothing but by taking the summation on both sides, we get the normal equation. Summation y, summation of a0. A0 is a constant and summation of 1 is n. If we add 1 n number of times, it gives us n. A1 is a constant, it will come out of summation side, and summation of x. You can use x or xi, no problem. Any notations you can use. Now multiply first equation by x and take summation again. So if you multiply by x, it becomes xy plus a0 x plus a1 x square. And if we take the summation of that, it becomes summation xi yi, a0 into summation x, a1 into summation x square. And now put the values of these summations and n from the table. Use the values from the table. Summation y is 24, n is 6, and summation xi is 21. So it becomes 24 is equal to 6a0 plus 21a1. Then summation xiy is 75, a0 into summation xi is 21, summation xi square is 91 into a1. Now we get two equations in two unknowns. Solve these two equations simultaneously. So if we solve it on calculator, two linear equation in two unknowns, we get these values. A0 is 5.7999, A1 is minus 0.5142. You can do this calculation on calculator directly. Okay. Now put these values of A0 and A1 into the given equation, the first equation. So value of y is 5.7999 minus 0.5142x. So this is the equation of straight line y on x. Okay. By using the regression also, we can get the similar equation. But here we doesn't require r, we doesn't require sigma x, we doesn't require sigma y, no x bar, y bar. Just by using these summations, we can get this equation of straight line. Okay, this method is called as a least square method. Okay, now it is asked to find the value of y when the some value for x is given, and whenever we want to find y when x is given, we use the equation of y on x. So use that value of given value of x. We are given x is 4, so put x equal to 4 into this and do the simplification. So y will be 5.799 minus 0.5142 into 4. So it comes up to be 3.743. Okay. So very easy, just simple single formula we have to remember. Then summation, multiply by x, again summation. Put these summations from the table and solve these equations simultaneously. Okay, using calculator also you can get these unknown terms. Now there is also we have to find the equation of x on y. So consider the equation of straight line x on y as x in terms of y, that is x is equal to say some b naught plus b1y. A naught, a1 already used, so use some another constants. You can take any notations. B naught plus b1y. Take the summation on both sides. It will be summation x, summation b naught will be b naught into summation 1. Summation 1 is n plus b1 into summation y. Now, as here x is there, multiply both the side by y and then again take summation. So if you multiply by y and if you take the summation, it will be summation yixi, b naught into summation y, b1 into summation y square. Use the tabular values, do the substitution. So if you use the tabular values, summation xi is 21, n is 6, b naught plus summation y is 24 into b1. Second equation is summation yixi. Yixi and xiy is one and the same. So take the value of summation xy from the table, 75. Summation y is 24, b naught as it is, b1 into summation y square, that is 106. Solve these two equations simultaneously. That gives us b naught as 7.1 and b1 is minus 0.9. And putting both these values back to the first equation, we get the straight line, that is x is equal to 7.1 minus 0.9 into y. Okay, so this is a straight line of the form x on y. And we are also given the value of y and it is asked to find x. So put that value of y over here. Y is 4 and we want corresponding x. So x will be 7.1 minus 0.9 into 4. So it comes up to be 3.5. Okay, so value of x is 3.5. Okay, so very easy and very, very important method. Just carefully remember the format of the table and way to solve it. Okay, it is not as difficult as regression, because in regression there are so many formulas we have to remember, formulas for r, sigma x, sigma y. There is no such case for this least square method. Okay, just properly using the tabular values, we can get the both lines, straight lines. Now we'll see how to fit a parabola. Suppose we are having the equation of degree 2, quadratic equation. Then how to get that curve from the tabular values? Similar method is there. Firstly, we have to consider the general equation. For fitting a quadratic curve, we have to consider the quadratic equation, quadratic curve, that is y is equal to some constant plus constant into x plus constant into x square, a naught plus a1x plus a2 x square. Now, as we are done for the straight line, do the same thing. First, take summation of this equation on both sides. So if I take the summation on both equation, then it become summation y. Summation of a naught will be a naught into summation 1. And if we add 1 n number of times, it gives us n. So it is n a naught, a1 into summation of x, a2 into summation of x square. Now, how many unknowns are there? A naught, a1, and a2. There are 3 unknown terms. So we must have 3 equations. Because if we have 3 equations and 3 unknowns, then only we can easily get the values of unknown terms. So we want 3 equations. Just now we got 1 equation. Now do the same thing what we have done for straight line. Multiply the first equation by x and take summation. So if you multiply first equation by x and if we take the summation of that, it becomes summation xi yi equal to a naught into summation of x plus a1 into summation x square plus a2 into summation of x cube. How we get this? Multiplying first equation by x and taking summation. Now, We want third equation, one more equation. So to get that equation, multiply this first equation by x square. Firstly, we take direct summation, then we multiply by x, then we take summation. Now multiply by x square and take summation. So if you multiply by x square, the first equation becomes y into x square, a naught x square, a1 x cube plus a2 x raised to 4. And if we take the summation of that, it becomes summation x square y equal to a naught summation x square, a1 summation x cube plus a2 summation x raised to 4. And now we get the three equations in terms of three unknowns, a naught, a1, and a2. Okay. Now solving these three equations simultaneously, we can get the values of a naught, a1, and a2. Okay. And substituting that equation back to first equation will give us the equation of quadratic curve. Okay. So again, remember the method. No separate formulas we use. We take the equation of curve. We take the summation of that. Multiplying by x, again take summation. Multiply by x square, take summation. Three equations, three unknowns. Solve that three equation on calculator. We can get the values of all three unknowns. And put all that unknowns in first equation gives us the quadratic curve. So it is a quadratic curve passing through the points which are given in the tabular form. Okay, I'll take the problem and we'll see how to make use of these equations to get the solution. So fit the least square quadratic curve to the following data. X is 1, 2, 3, 4, and values of y are 1.7, 1.8, 2.3, 3.2, and estimate y at 2.4. Okay, this meaning of this is we have to find a value of y at x is equal to 2.4. We have to find the equation of y in terms of x, and then we have to take x as 2.4. Now quadratic curve, we know the standard formula y is equal to a naught plus a1x plus a2 x square. And for getting three equations, we need what we need to make some columns in the table. So what are the columns we need? We need to make x square, xy, x cube, x raised to 4, and x square y. Okay, these 5 extra columns we have to make. Okay, because we are having three equations and all that equation, these summations. So we have to make these extra columns. Now we know how to do the calculations. Take square of each x term, that gives us x square, 1 square, it will be 1, 2 square is 4, 3 square 9, 16. Then x into y, 1 into 1.7, 2 into 1.8, 3 into 2.3, 4 into 3.2. That will be x into y. X cube, if you want, you can directly take a cube of these terms. 1 cube, 2 cube, 3 cube, 4 cube. Then x raised to 4. Take the fourth power of these terms or multiply x cube into x. 1 into 1 to 8 into 2, like that. Also, you can get the x raised to 4 terms. And the last term, x square into y. Take the product of second and third columns. That gives us x square y. Okay. After completing the table, take the sum of each column. Simple summation of each column. Summation x is 10, summation y 9, summation x square is 30, summation xy is 25, summation x cube is 100, summation of x raised to 4, 354, x square y is 80.8. How many observations are there? There are total 4 observations. So n is 4. Now use that normal equations. Okay, firstly we have to form normal equations from the quadratic curve. So considering the quadratic curve, y is equal to a naught plus a1x plus a2x square. Take the summation on both sides. That gives us the first equation. Then multiply by x and then take summation. Multiply by x square and again take summation. Okay, so by taking direct summation, we get this first equation. Multiplying by x, taking summation, multiplying by x square, and again taking summation. Okay. These all x and y are capital X and y. By mistake, I have taken small x and y. It is all are capital X and y. Okay. Now, use the tabular values of the summations. N is 4. So using the tabular values, summation y is 9, summation xy is 25, summation x square y 80.8. Like that, using all the values from the table, we get these three equations. And on calculator, we can solve three linear equations in three unknowns. So properly put these constant terms and put this terms on the other side into the equation, and that uses the values of a0, a1, and a2. a0 is 2, a1 is minus 0.5, a2 is 0.2, and put these values into first equation, putting this into this first equation. So y is equal to 2 minus 0.5x plus 0.2 x square. And it is asked to find the value of y when x is 2.4. So just put x equal to 2.4 into right hand side of the equation. That gives us y as 1.952. Okay. So this quadratic curve also similar method as that of straight line. Taking summation, multiplying by x, again taking summation, multiplying by x square. That is one more step we have to do here to get the third equation. And then three equation, three unknown, solving simultaneously and getting the values of unknown term, putting into equation, we get the equation of quadratic curve. Now how multiple choice question will be there on this? We are given a quadratic curve, equation of this quadratic curve, and it may be asked what are the normal equations, or we are given all the summations, and then it may be asked what are the a0, a1, a2. Okay. Generally up to two variables, means up to line, it may be asked to solve two equation into unknowns. Three equation in three unknowns, that will be quite difficult to ask because it will take some time. So three equation in three unknowns, these equations will not ask. But what are the normal equations that may be asked for multiple choice question? Okay, so only these three equations, how we get, if you remember that, you can easily solve the problem. Okay, or we are given a quadratic curve, value of x is given, what is the value of y? Just substitution we have to do to get the value of y. Okay, like that we are having some more equations of the line. Exactly by the same way we can also get the nth order polynomial. Okay, for that, how many unknown terms are there? Up to that we have to get the number of equations. If there are n unknowns, then try to get n equations. And how to get n equation? Firstly, multiply by x, take summation. Multiply by x square, take summation. Multiply by x cube, take summation. Like that, try to get n equations. Now, what to do if we want to fit the exponential curve? Now, what is the exponential curve? The exponential curve is the curve of the form y is equal to a into b raised to x. A and b are any numbers, any real numbers. It may be positive, negative, or it may be non-integers also. Okay. So how to get this equation? So there is one extra step we have to do. Rest of the part will be same as previous type, but only one extra step we have to do is we have to take a logarithm on both sides. Okay, what to do? First take log on both sides. If you are having anything in the power and if you want to simplify that equation, it can be easily done by using log. So if you take log on both sides, then what happened? Log y is equal to log of a into b raised to x. And what is the property of log? If you are having the multiplication, the log of a into b raised to x become log a plus log of b raised to x. And log of b raised to x is x log b. Okay, so we are using the properties of log. Log of a into b is log a plus log b, and log of some a raised to constant term. We can take that constant term outside. So it is log of a raised to n will be n log a. So by using that properties, it become x log b. Now, which terms are there in log? use different notations for that. Log y, you can denote it by say y star, log a denoted by a star, log b denoted by b star. Just using the some different notation for all log terms. Single terms, you keep it as it is. Single x is there, you keep it as it is. So what happened? We get the equation y star is equal to a star plus log b as b star into x. And you can see that this is nothing but the equation of a straight line. Y is equal to a naught plus a1x. It is similar to that, only notations are different. Instead of y, we are having y star. Instead of a naught, we are having a star. Instead of a1, we are having b star and x. And we know how to solve, how to get the equation of a straight line by least square method. We have to take a summation of this, and we get one equation, then multiply it by x and get the second equation. Take the summation of that both equations and solve simultaneously. Find the values of a star and b star. And after getting a star, take its antilog to get a. If you want to find the value of a from this a star, then take antilog. And then we get a and b, and put a and b back to this equation, gives us y. So it is exactly same as that of straight line. Only one extra step we have to remember for this exponential curve is we have to take a logarithm. Simplify it and then replace log of the variable by that variable star, notation by star, and it become a straight line, equation of a straight line. And the rest of the process will be same as that of straight line. Okay, so only this step is very important, taking log. Okay, now we'll take a problem based on this. Fit a curve y is equal to a b raised to x using the following data. X is 2, 4, 6, 8, 10, 12. Y is 7.32, 8.24, 9.20, 10.19, 11.01, 12.05. Find out values of a and b. Okay. Now, if you are having a simple linear equation, we directly use that equation and we simplify it. But here we are having something raised to x. So to simplify it, firstly, we have to take a log of that equation. So first, take the given equation, y is equal to ab raised to x. Take log on both sides. So log y will be log of a b raised to x. And log of a b raised to x is log a plus log of b raised to x. And log of b raised to x is x log b. Okay. Now use the notation star for log of the variables. Log y is y star, log a star, log b star. Single terms, keep it as it is. Okay. So it becomes y star equal to a star plus b star x. Now, we want to find what are a star and b star. So first of all, find what are the normal equations of this. And we know how to get the normal equation. Just take the summation of this equation. So if I take the summation, it will be summation y star, a star into summation 1 is n, b star into summation x. Now to get the second equation, multiply it by this variable x and again take summation. So it is summation x y star equal to a star summation x, b star summation x square. Okay. Now what we need in this, we need what is summation y star, summation x y star, summation x and summation x star. So whichever summation we need, accordingly, we have to make the extra columns in the table. So we need what is y star, we need what is x y star and x square. So we have to make these extra columns of y star, column of x y star and column of x square. Okay, so depending on these two equations, we have to decide which columns we want. Okay, so accordingly, we want to prepare the table. So take the values of x, y, make extra column of y star, and y star is nothing but log y. Okay, so accordingly, find the log of each term, then x, y star, and x square. Okay, so these three columns we have to make x for. Y star is log y. So what are the terms are there? You take log of that. Okay, there are two types of log on calculator. It is log of something or ln. There are two notations on calculator, log or ln. You can use any of that, but throughout keep the same notation. Use the same term on the calculator. And while taking antilog of a log, we take 10 raised to x. And while taking antilog of ln, we take e raised to x. This log is a log to the base 10, and ln is a log to the base e. So while taking antilog of this log term, we take 10 raised to x, and while taking antilog of ln function, we take e raised to x. So that care we have to take. Otherwise, it is regular calculation. Okay, so complete the table. Find the square of x, multiply x and y star. Okay, take the sum of each column. Here summation doesn't read, so no need to take the summation of y. Rest of the summation we need. And total number of terms, there are 6 terms are there, so n is 6. Okay, so use these tabular values and n as 6. Get the two equations. Put these values in normal equation. So these are the two normal equations we have. And now solve these two equations simultaneously. Get the values of a star and b star. So a star is a log a, that will be 0.829. B star is nothing but log b, that will be 0.021. Take antilog of it. If you take an log, then take 10 raised to this value, that will be b. If you have taken ln, then take e raised to this value. If you take a log, then take 10 raised to this, and if you have taken ln, then take e raised to this. Okay, so that gives us a and b, and putting that a and b back to the equation become y is equal to 6.745 into 1.049 raised to x. Okay, so these are the this is the way. The first important step in solving this equation is taking log. After taking log of whichever term is there, replace it by star, y star, a star, like that. Do the replacement. It becomes a straight line. And we know how to do simplify straight line, how to get a normal equation of straight line. Use that way, make the corresponding columns in the table and solve it simultaneously. Get the equation of the corresponding curve. Similar ways is used for solving the last type of curve, that is a geometric curve. Generally the geometric curve is given by y is equal to ax raised to b. And if you are having anything in the power, it can be simplified by taking log term. So take log on both sides. So log y will be log of a into x raised to b. And log of a into something, that will be log a plus log of x raised to b. And log of x raised to b is b log x. And log of whichever term is there, replace it by star. So it is y star, a star, and log x will be x star. So it will be y star equal to a star plus b x star. Okay, and this is again equation of a straight line. Only thing is equation is in terms of y star and x star. These are the constant terms. So first equation we get by taking the sum on both sides, and for getting the second equation we have to multiply by this variable, that is x star. If you're having x here, then we multiply by x. If you're having x star, then we have to multiply by x star and then take summation. So rest of the part will be same as that of straight line. Okay, getting the normal equation and solving the two equations simultaneously. So same method for geometric as well as the previous exponential curve, taking log, then getting the straight line, taking summation, multiplying by x or x star, whichever term is there, accordingly take the summation, solve it, get the values of these unknown terms. And if it is star, don't forget to take its antilog. If it is no star, it will be the actual value, means directly we get the value. Okay, so we'll take a problem, a simple problem on this, and then we'll stop. Fit the curve y is equal to ax raised to b using the following data and find the values of a and b. Okay, so again we are given some tabular values of x and y, and we want to fit y equal to ax raised to b. Something raised to some terms is there. So firstly, take log on both sides. Log y will be log of a plus b log x. Replace these log terms by star. So it is y star log a star log x star. So y star is equal to a star plus b x star. Okay. Now take summation on both sides. So summation y will be a star into summation 1, that is n, plus b into summation x star. This is the first equation. Now here we are not having x, we are having x star. So multiply this equation by x star and then take summation. So it will be summation x star y star equal to a star into summation x star plus b into summation x star square. Okay, here carefully take the term. If x star is there, multiply by x star. If x is there, multiply by x. Okay, that care we have to take. So these are the normal equations. And now we want these summations. So make the columns accordingly. We need summation y star. So we need to make one extra column y star. We need x star. So take the column x star y star column x star square. So we need to make 1, 2, 3, 4 extra columns. Okay, and then using that summations, we get the normal equation. So what are the columns? X star will be log x, y star is log y, x star square, and x star y star. Okay, now just complete the table. Summation of summation xy, we have the rest before we have to take summations. Put these values back to both equations, both normal equations. Solve them simultaneously. It gives us the values of a star and b. B we get directly, but here we get a star, but we want a. So don't forget to take its antilog. So these are the values of a and b. Okay, and putting a and b into first equation, we can get the equation of geometric curve.